Awesome. Thank you, Jason. Hello, everybody. Thank you all for attending. My name is Charles Oxyer, Product Manager for Defender for DevOps, joined today with Liana Tomescu, fellow Product Manager, and together we're going to showcase Microsoft Defender for DevOps, Defender for Cloud's newest offering to shift your security left and unify your security management across DevOps platforms, transforming Microsoft Defender for Cloud into a comprehensive cloud-native application protection platform. Now, before we get into the demo and showing off our product, I want to go through a little of why Defender for DevOps exists and what problems we aim to solve. First, we have fragmented visibility. Over 54% of enterprises do not integrate security into DevOps CI/CD pipelines. Developers are building and deploying code into production, yet the security team has no visibility on what vulnerabilities and misconfigurations may exist within this code. Additionally, more than half of enterprises are concerned over rogue applications and compute instances. Now that more and more cloud infrastructure, container images are all built and deployed through code, security teams monitoring the runtime of their cloud workloads have no idea which repositories and which developer owners are in charge of remediation. They have no way to tie back their cloud workload to the line of code that deployed it, making it hard to ensure rapid remediation when issues arise. Next, we have lack of insights. Over 34% of enterprises lack developer buy-in of security tools due to inadequate automation and prioritization. Even when you do configure static analysis tools in those developer CI/CD pipelines, they typically are met with hundreds of results and alerts that get thrown through each build, making it difficult for developers to prioritize and quickly remediate those most critical vulnerabilities. Lastly, we noticed that DevOps and security silos typically come with a complex conversation and navigating how to maintain a high level of developer velocity while also ensuring that the security needs of your organization are met. To address these problems, we've established the new quadrant within this Microsoft Cloud Native Application Protection Platform, DevSecOps. Our product exists alongside your CIEM, Cloud Workload Protection, and Cloud Security Posture Management to shift your security left and ensure that your misconfigurations and vulnerabilities are addressed before they even reach the production stage, ensuring that from build time to deploy time to runtime, we embed security into every stage of the cloud native application lifecycle. Within Defender for DevOps, we have 4 key value pillars to unify your DevOps security. First is DevOps Security Posture Management, providing the security team with visibility into the vulnerabilities that exist within your code, dependencies, the secrets in your code base, when vulnerabilities are identified in container images, and infrastructure as code security insights. With infrastructure as code security, more and more cloud infrastructure is deployed through your ARM, Bicep, Terraform, CloudFormation, and additional IAC templates. Through enabling developers to identify the misconfigurations before they reach production, you can ensure that the attack vectors in your production environment are minimized due to the developers being empowered to remediate these issues quickly and before they reach the production stage. Next, we have code to cloud contextualization. You may be familiar with the Cloud Security Graph and Cloud Security Explorer that exists in Defender for Cloud today. We've enriched this Cloud Security Explorer with the data coming from Defender for DevOps and offer attack path analysis for security teams to prioritize your most critical issues. Lastly, we have integrated workflows, empowering the developer to remediate issues quickly through pull request annotations, where any vulnerabilities are mapped directly to the line of code and are met with remediation guidance as well, so developers can get back to doing what they do best, shipping high quality code at a rapid velocity. Lastly, we have developer ownership assignments. So the security team, when they're looking into this security posture across their DevOps environments, can assign the developer owner who's in charge of remediation to ensure a rapid time to remediation. I'm now going to pass things off to Liana to go over the Better Together story with GitHub Advanced Security.
Great. Thank you so much, Charles. That was a super introduction. So basically now I'm going to tell you how Defender for DevOps works with GitHub Advanced Security. So what we currently have in GitHub is Defender for DevOps has a partnership with GitHub Advanced Security. And what GitHub Advanced Security brings you are several security capabilities. And these include code security, which is basically scanning your code for any security issues. And it's doing that via CodeQL. We also have dependency security, which is actually checking for any open source security issues with Dependabot. And then last but not least, on the GitHub Advanced Security side of the main capabilities that it brings us are the embedded secrets protection, which is basically looking at scanning your GitHub repositories to see, are there any secrets in those repositories? And then giving you the advice, well, you know, in general, it's not a good practice to have secrets in there. So it's a good idea to know about any of these security issues, code dependencies with open source, and if there's any secrets. And this is all part of the GitHub Advanced Security side. And then when we're talking about Defender for DevOps, so what are the capabilities that Defender for DevOps brings in addition to the GitHub Advanced Security? Well, there's loads of them. And the first one that we have on the screen is our multi-pipeline DevOps security management. So actually this encompasses a few things. I'll talk about a few things. So when we're talking about multi-pipeline DevOps security management, it means that we're not just covering just GitHub, but we can also protect your Azure DevOps code as well. So that's bringing in all the security results from both GitHub and Azure DevOps into Defender for Cloud via Defender for DevOps. And then in addition to seeing it in that way, the other capabilities that we have, well, we have something called MSDO, which is Microsoft Security DevOps extension. And that's available for both GitHub and Azure DevOps. So with MSDO, and I have a slide actually going into it in more detail, but we can do several things that are SAST scanning, which is static application security testing scanning. And we have a bunch of tools in there, like looking at checking for security misconfigurations in JavaScript code or Python code, and then there's others. But also in that MSDO extension, what we have is infrastructure as code scanning. And that is actually checking for your infrastructure as code templates. So say, for example, Terraform, ARM, Bicep, and then doing scans to see, are there any security misconfigurations in there? And then informing you about this. And this actually covers templates, infrastructure as code templates, not just for if you're trying to deploy resources to Azure or trying to manage resources to Azure, but also to multi-cloud environments as well, so to AWS and GCP. So that means that even if there's any security misconfigurations in your Terraform file, for example, if you're trying to deploy something to AWS, then we will be able to detect that as well. So it's multi-pipeline and multi-cloud as well from that perspective. And our second one that we have under Defender for DevOps is our code to cloud contextualization. And Charles also talked about this one earlier, but basically that once again just brings extra context about the repositories, but it brings that context into MDC, into Defender for Cloud, where that information is then queryable. And that is actually via our Defender CSPM plan. So you can actually use Cloud Security Explorer to do proactive threat hunting there. And this also is this is also where the attack paths come in as well. So Charles will demo this near the end of the presentation as well. And then last but not least is our automated workflows. So Charles also called this out, but basically we are bringing integrated workflows that are for developers so that they can be made aware of the security issues that have been found, and they can be made aware of them via what we call pull request annotations. And what that means is you can think of pull request annotations as basically comments in the pull request that informs the developer whenever there are security issues. So for example, if secrets have been found in the pull request, say someone is trying to go from a developer branch, they've opened up a pull request going from a developer branch into a main branch, then those secrets will be determined. Those secrets, the developer will be able to see them in the pull request annotation. And then once they have that knowledge, once they're empowered with that knowledge, then they're able to, take action on those and remove those security issues. And that altogether means that those security issues, like those secrets, they don't get into production code. And this altogether leads to overall improved security posture. So with GitHub Advanced Security and Defender for DevOps, we get improved security posture across the board from code to cloud. So I called out our Microsoft Security DevOps extension, but let's just briefly go into what that is. So first of all, we can use our MSDO extension, Microsoft Security DevOps extension, for both GitHub and Azure DevOps, and it comes with Defender for DevOps. And what this extension does is it does SAST scanning. So I called this out earlier, but just a reminder, SAST scanning is static application security testing. And you can see a list of the tools that we have. This is taken from our GitHub list. And what that means is that when you enable the Microsoft Security DevOps extension to run on, for example, an Azure pipeline, then these tools will run, assuming you've allowed all of them to run, and we'll go into those details in the demo. But assuming you've enabled all of these, then if any security issues have been found that each of these security tools scan for, well, then you will be informed. Your developers will be informed about this. And yeah, so basically let me quickly kind of run through what each of these are. So first of all, we've got anti-malware, and the anti-malware capability is our newest tool, and it's a very powerful capability that checks for, is there any malware in your in a deployment that is going to your Windows agent. So this actually comes out of the box if you're using the Windows latest agent, so you don't need to do anything. And then so it'll basically scan the source code. If malware has been found, then it will basically break that build. So it's very, very powerful for checking if there's malware at the build stage. So the next one we have is Bandit, and our Bandit tool checks Python code to see, are there any Python security issues that your developers should be aware of? And next up, we've got BinSkim, which looks at binary files for security issues, ESLint, which looks at JavaScript files, and then Template Analyzer and TerrorScan is the two tools that I called out earlier as part of our infrastructure as code capabilities. So they're checking for, you can see ARM templates, bicep files, Terraform files, CloudFormation, and so on, if there's any security misconfigurations with those. And then last but not least, we have Trivy that scans several of the capabilities that we have on the screen. So now that you've gotten that overall introduction, we wanted to make this whole webinar very real. So we actually have the whole rest of the presentation is a demo for you now. So let's go for it. Okay, so here I am in Defender for Cloud. And I'm zoomed in a little bit so you can see. So in Defender for Cloud, this is in general where your security people will actually sit. So the first thing that we want to do in terms of Defender for DevOps is that we actually want to create a connector that will connect either our Azure DevOps environment or our GitHub environments to Defender for Cloud, so that they will be protected also from Defender for Cloud. So the way to do that, the way to configure that is we need to go to environment settings. Okay, and here in environment settings, we basically have all of our environments, including our Azure subscriptions and so on. But what we want to do now is we want to add a non-Azure environment to be protected by Defender for Cloud. And the way that we can do that is by going up here where you can add an environment. And this is the same place where you can add AWS and GCP. And here we have the ability to add the GitHub connector or the Azure DevOps connector. So I'll start with Azure DevOps because I'll be focusing on showing you Azure DevOps. And this basically is the 4-step process to creating the connector. It is super easy, as you'll see now. So the first thing that we need to do is actually give the connector some details. So for example, we can say this is going to be our ADO from the webinar. That's the name of the connector. You select the subscription and you select the resource group, or you can create a new one. So I'll just say webinar for the moment. And then you select the region. And the region that I'm going to select in my case is West Europe because I'm in Dublin. So for GDPR reasons, I'm going to select this one. And then afterwards, we go into select plans. So here we're able to actually make sure that the Defender for DevOps plan is enabled. So this is the same way that you would enable any of the other workload plans that we have in Defender for Cloud. So say, for example, you want to enable Defender for storage or something, you can do that from the environment settings. But in this case, we're enabling Defender for DevOps at the connector level. So you just need to make sure it's switched on. And then the third step is where you actually authorize the connection. So in terms of authorizing the connection, this is the step that actually does the connection with Azure DevOps. And the very first time that you do this, when you press authorize, you'll just have to basically sign into your Azure DevOps environment. And so I'll just, now that I've actually already done that, so it automatically fills it in for me, but it's just very few kind of steps in between there. And one thing that I do want to call out about this is that when we're talking about enabling the Azure DevOps connector, we can only enable the connector on the same tenant that the Azure subscription is in. So in this case, this is the tenant that I'm in. We can only authorize the connection with Azure DevOps if that Azure DevOps environment is in the same tenant. So that's very important for you to bear in mind. And then we're able to actually edit the connector account, and that's really talking about which organizations, which projects, which repositories do we want to protect. So in this case, I just have one in my demo environment, and then you can do either an auto discovery of all the projects. And that means that the current projects, but also any future projects that you may that may be included in the organization. Or else you can just be more specific for you only want to protect these projects. So you can just select like one project, for example. And then as well as that, you can also then go drill down another level. So be even more granular, saying which repositories do you actually want to protect. So again, you can do auto discovery of repositories, or you can actually, again, select a repository. So in my case, I'm just going to do an auto discovery of projects. And then you have a few permissions there. So some customers have asked, why do we have some of the write permissions? And basically, because as both myself and Charles were saying earlier, we do have the PR annotations, those comments that we, they're kind of comment-like descriptions of the security issues that are found in the PRs, and we do need to have some write permissions to be able to include those in there as well. So once we've done these 3 steps, connector details, select plans, and authorize the connection, then we just do a review and create, press create, and that will, within a few seconds, then you'll actually see the connector in place. So I'm not going to do that just because I've actually already done it. And then what will happen is, you can actually see underneath, you will see that we will have this Azure DevOps connector pane, and then we'll have our connector there. So your connector will appear under the environment settings as another environment that you are protecting. And then after up to 8 hours later, you will also have all of the repositories that you have selected to be protected, they will then appear in our new DevOps Security Blade. So the DevOps Security Blade is very powerful because it gives you an overview of everything that you have in your Defender for Cloud, or most things that you have in your Defender for DevOps protection. So in here, you can basically see some overview information that we have. So you can see some of the code scanning findings. You can see some of the all-up DevOps security results. You can see some of the DevOps coverage, how many connectors do we have, repositories, and so on. And then underneath here, you can see a list of all of the repositories that we're actually protecting. And you're able to select either GitHub or Azure DevOps. So I'm just going to select Azure DevOps because I want to show you how to start the enablement of pure annotations from here. So here you can see, again, a list of all of my Azure DevOps repositories, and you can see the pull request status is on for several of these repositories, but it's actually off for this one. So I want to enable it. How do we do this? And the first step that we need to do for that is actually from here, from Defender for Cloud, from this blade. We need to select that repository, and then we need to configure it up here, and then we're able to turn on pull request annotation. So we're giving our permissions to inform the developer about the security issues found from here on the pull request annotation level. And for now, we're able to protect to determine any secrets. We're able to inform the developer about secrets that have been found in Azure DevOps. And so we want to turn that on, and then we're going to select the severity to be high. So if there's any high severity secrets that are found in the build of the Azure DevOps pipeline, of the Azure pipeline, well, then those secrets will appear in the pull request annotation for the developer to fix. So then we're basically going to press save for this one, and that will be the first step of turning on the pull request annotations. So what I'll actually do as that is going is I'll show you then the second step of how to enable the pull request annotations. So what we've done is the first step, which is from Defender for Cloud, and you do need to be a security admin. You do need to have the role of security admin to enable it from Defender for Cloud. But now in Azure DevOps itself, I'll walk you through the steps that the developer or DevOps team need to do in order to configure the pull request annotations from here. So I'm in my Azure DevOps project. I'm going to go into project settings. And then I am going to go down. We're going to find the repository and basically add a build validation policy to the repository. And once we find the repository, so let's say I'm selecting vulnerable repository. In our vulnerable repository, we're going to add a policy. Like I said, we're going to add a policy, which is a build validation policy, which requires a build to be validated before for the pull request to run. So then we actually need to select the branch policy. So once we select the branch policy, and I've basically selected main. So in general, most customers are using main or master branch. That's what they're allowing the pull request annotations to be on, but you can select whichever one works for you. And then we go down here, and this is the build validation. So you can either create a new one or you can edit an existing one. So basically, what you need to do is have all of the default capabilities enabled. So for this, for our main branch in that vulnerable repo repository, we're going to say that we need to have this build pipeline running, and it needs to trigger automatically when the source branch is updated, and then this is required as well. So we're going to basically save that. This build validation needs to be enabled, and then afterwards, then we'll be able to see the pull request annotations. So, now I've showed you how to set up the connector in Defender for Cloud. I have showed you how to turn on pull request annotations for Azure DevOps. in Defender for Cloud, but now also I've showed you how to finalize the pull request annotation configuration from here from Azure DevOps. So now let's talk about how you can actually get all of the MSDO scans that I showed you earlier. So in order to do that, the very first step that we need to do is we need to make sure that we actually have our extensions enabled. And so that is the Microsoft Security DevOps extension, the MSDO extension, what we call it, and then also one other extension as well. So you can go into the marketplace there. So if you actually do go, you can browse the marketplace or manage the extensions. So I've just opened it up here separately. Here I'm managing the extensions, and these basically are the two extensions that you need to have. So we need to have the Microsoft Security DevOps extension. That's the most important one because that's the one that actually has all of the security scans that I told you about earlier in MSDO. Then this one is Serif SAS Scans tab. And what this one does is it actually basically shows you the results of them when this extension runs. So it shows you those security issues, but in a nicely formatted way in a new tab. So, and that's for your DevOps person. And so you can do that from browsing the market. You can get these from browsing the marketplace. They're free of charge. So it's a very simple process. So now, once you've done that, once you actually have your, these extensions, then what we need to do is, assuming that you already have a repository with code in place, and then the next thing is we actually want to run a build. We want to create an Azure pipeline that contains this Microsoft Security DevOps task that will do the security scans. So where we do that from is, if I go back in here for a second, I'm basically going to go into the pipelines. And in here, okay, cool. So in here, you can see that I have several pipelines that I've created already. If you want to create a new pipeline, you can do it from here and kind of follow through this, go into Azure repos, select the repository that you want to do this from, and then create the YAML file and so on. I'm just going to show you an existing one, and I'll show you what you actually need to have in it. So what I'll actually do is I'll just go and select one of these, and you can kind of see what we have in the repository, but I'll just, in the YAML file for it, but I'll just let it run just so we can see what that looks like as well directly. And in the meantime, while that is actually running, let me show you what we have in the YAML file itself, so you can see what are the things that you need to have. So I'm just going to edit one of these YAML files, and just so I can go through some of these. So this is the bare minimum of what you need to have in order for this build to run on this Azure pipeline. And the whole thing is you need to have a trigger that is on the main. Well, in my case, I have it on the main branch, but you can have it on whichever branch you need. You need to set up an agent to actually run this on. And in my case, I'm using Windows Latest, which is actually one of the agents they're the default agents that come with Azure DevOps. And the benefit of using one of these agents is that you don't need any of the .NET dependencies that are associated with our Microsoft Security DevOps task. If you're using a custom agent, so just bearing in mind, and we do have this in our documentation, that you will need some .NET dependencies if you're using a custom agent. And just keep an eye out on our documentation for that. But because we are using our Azure DevOps default agent, then we basically can just go ahead with the task, and it's Microsoft Security DevOps task, and we've got our display name. So it's very it's very simple for that in that way. And if I just click on settings, I do want to show you some additional capabilities that we can have in here, because I think it's worthwhile for you to be aware of. So here you can do some configuration for the Microsoft Security DevOps task. And some of the ones that I'd like to call out are that you've got several categories, languages, and tools in place. And in general, the default is if you don't specify anything extra, well, then it defaults to all. So all of the Microsoft Security DevOps tools that I showed you earlier, they will all run and check for security misconfigurations with any of those. including as well anti-malware on Windows latest. If you do specify any of these, well, then it just goes for it just runs the ones that you've selected. So that's categories. You can also select languages, and you can select specific tools again. So these are some of our tools that we have. One useful thing for you to bear in mind is that when this runs, if it runs as it is now, even if any secrets or any code misconfigurations or infrastructure as code issues have been discovered, well, then what that actually what happens is that the build will still pass. Those security issues will be there. They'll be available for your DevOps person or your dev to see, or your security person in Defender for Cloud, but the build will still pass. If you want to break the build, you do need to enable the break build capability, and then make sure that you're including it in there, and then that means that the build will fail. So that's something to bear in mind. Now, what I also want to show you is actually want to show you what the results of this would look like. So in general, when we're talking about the build, when we're talking about seeing the results, it may be your DevOps people that may want to have a look at the results in here. So in this case, the build has discovered that we've got several credentials that are actually in our repository. And then we've also got some warnings as well, where we have a terror scan warning there also. And if we click on it, that will give us some extra information, like ensure that Azure Virtual Network subnet is configured. One kind of nicer way to see this, if I just press back, as well as seeing all the results there. So this is, very powerful, but we do also have this scans tab, and that's what that second extension actually does. It gives us that tab. The security DevOps extension is for the actual build for all of the security scans, but this one shows us the results in a nice to view format in here. So this may be for your DevOps people to have a look at this from here. But what about your developers? So your developers may not necessarily go and have a look at the build stage from here. Where they may go instead is they may be looking at the pull requests. And I do have a sample pull request that also has some pull request annotations. So I will show you this here. To save some time, I'll show you this one that I've already created. And what we have here is that I had a temp branch that I opened up a pull request to get the changes from the temp branch into the main branch. And if I was a developer, I would be coming in here and I would be, approving this and then, making sure that it's complete. But first of all, before we do any of that, I do want to show you that in this case, we have actually found several issues. We found some keys that are available in our branch here, in our temp branch. So what the developer would want to do is make sure that these secrets don't make it into the production code, because that is not good practice. Instead, the developers should use something like a key vault, an Azure key vault or something like that. And then that would mean that the repository is extra secure. Your production environments won't have these secrets, and it leads to better security all up. So now what I've basically showed you, if I take a step back, what I've showed you now is how you can do the build pipeline with the YAML file and including that security DevOps extension. And then how the DevOps people may see the results in the scans tab. I've also showed you how the developer could see the secrets that have been tried to be included into our main branch in here in the pull request annotations. And they then can take action on these, make sure to get rid of them. And then the other place that Charles will actually show you is how the security person can see all of these results from a Defender for Cloud as well, because we do want to make sure that the security person is able to manage this whole thing from Defender for Cloud. But the very next step that I think Charles will show you next is how to enable all of these capabilities and GitHub Advanced Security, but on GitHub. So I've showed you the Azure DevOps side. Charles will cover the GitHub side and then show you the Defender for cloud side. So Charles, I will hand it over to you.
Thank you, Liana, and great demo of our Azure DevOps capabilities. Now I'm going to take over the screen here and show off our GitHub onboarding flow and the capabilities that we provide for both Azure DevOps and GitHub within Defender for Cloud. Now, as you have seen, Liana showed how to onboard Azure DevOps, but we see many organizations not just using one single DevOps platform. Developers are typically spread across multiple pipelines, different source code management systems, and we want to offer this single pane of glass within Defender for DevOps. So if we add our GitHub environment here, so you'll see a very familiar onboarding flow. I'm going to quickly go through this beginning connector details stage, as you've already seen it demoed by Liana, selecting Central US as my region. For plan, very similarly, you'll see the DevOps plan will be enabled, and then we'll go into authorized connection. Our GitHub onboarding is slightly more nuanced than Azure DevOps, as you first need to grant us authorization to your GitHub auth token, which I will do here. And once you're authorized, you need to install our Defender for DevOps app on your organization. When you click install, you'll see the list of organizations that you have access to. I've already installed it on mine, so I won't go through here. But once you install it to your organization, you'll be able to select which repositories you want the Defender for DevOps app to have access to. After this stage, you would typically go through the same review and create process, and your GitHub repositories would show up in Defender for DevOps, just as you saw with with Azure DevOps. So navigating back to the DFD blade here, we can see a combination of GitHub and Azure DevOps repositories within our inventory. You're able to filter these by the resource type and get a single pane of glass view across your secrets, your dependency vulnerabilities, infrastructure as code vulnerabilities, and total code scanning vulnerabilities. Now, one note about GitHub is that for private repositories to be onboarded and to be able to take advantage of Defender for DevOps' rich set of capabilities, you do need GitHub Advanced Security. If you would like to test GitHub Advanced Security to see it's the security value that both GitHub and Defender for DevOps to provide, there is a 30-day free trial where you can sign up and explore and test within your test environments. Now, one of the repositories that I onboarded here to Defender for DevOps is this test repo that I created. Within this test repo, I have a simple ARM template, appservices.json, which is going to deploy Azure App Services API app. Now, very basic, but if I'm a developer, how do I know that what I'm going to provision into my cloud workload is configured securely to ensure that the attack surface is minimized in my production environment? Well, this is where the Microsoft Security DevOps action, GitHub action comes in. Just as you saw for Azure DevOps, you can configure the MSDO GitHub action as a workflow into your repository to ensure the same tools that you saw previously are scanned on your GitHub repository. As an example, I'm going to go through and click Actions, New Workflow, set up a workflow yourself, and here you will see a blank YAML file. All you'll need to do is go to our documentation on learn.microsoft and copy and paste this sample action to ensure that our analyzers are run on your CI/CD pipelines. Now, I've already configured the action, so I'm going to discard this. But when you want to view the workload and the YAML file, this is what it should look like in your GitHub environment. After a CI/CD pipeline is ran with this YAML file, you can go to your security tab. to ensure that to see all of the vulnerabilities that were identified. Be sure before running the action to enable Dependabot, code scanning, and secret scanning alerts to ensure full coverage of security across your repositories. When we go into code scanning here, we see that Template Analyzer identified these 6 critical infrastructure as code misconfigurations in my API app. Now, this is great for the developer, as I can see exactly where the issues exist. But what if I want to see it even earlier, as these are already in my master branch? The same set of capabilities that you saw for Azure DevOps exists within GitHub. Before I merged this branch into main, I could see directly in my pull request exactly where the infrastructure as code misconfigurations were presented in my JSON file, as well as the ability to set different dismissal alerts for each one, assuming that there's a chance it could be a false positive, that this repository is simply a test environment, or that the alert just isn't relevant. Now, we can see that the developer has a remediation path and visibility into the security vulnerabilities of their GitHub repo. But what about the security team? Security team isn't going into these DevOps platforms, going to shift through all of these repositories and into the security tabs of each one just to get an understanding of what the security posture of their environments is. This just isn't scalable. Thankfully, with the Defender for Cloud and just Microsoft Defender for DevOps Blade, you're able to see all the same information aggregated into one single location. For example, if I search for the repository I just showed, I can see the exact same 6 IAC scanning vulnerabilities that were showing in my repository right here in the DFD Blade, alongside all my other GitHub repos and Azure DevOps repositories. These aggregated results aggregated across your entire DevOps coverage, across all 57 of these GitHub repositories and 9 Azure DevOps repositories. I can see all 316 vulnerabilities that exist in my DevOps environments, sorted by category, as well as individual result aggregations across each different security category. Now, when we go into recommendations, you may be familiar with the same Defender for Cloud recommendations for your runtime cloud workloads. However, we've brought a similar experience with DevOps, where when you look into the remediate vulnerabilities, you can see the same recommendations that you may receive for your runtime environments for your DevOps environments. That code repositories should have code, secret, dependency, and infrastructure as code scanning findings resolved. When I go into the recommendation here, I get a high-level view of all of the security checks that were found and all of the rule violations from Template Analyzer, as well as the severity level of each one. When I click through each security check, I get additional metadata, such as the description of the issue, the repository URL, whether it's coming from Azure DevOps or GitHub, what the file path is, and even what branch that the misconfiguration was identified on. If I go into my affected resources, I can see all the repositories where a vulnerability was found, the last change date, as well as the ability to assign an owner. You can change the owner and set an ETA for remediation. The developer will then get a weekly cadence of emails reminding them of this remediation fix for them to do. This exists across all 4 of the code scanning, infrastructure as code scanning, secret scanning, and dependency scanning findings that we find. We even have recommendations for Dependabot, secret scanning, and code scanning to be enabled for your GitHub repositories. So if developers aren't using GitHub Advanced Security for your repositories, you will be shown this within recommendations. Now, I'm going to navigate to Cloud Security Explorer, a capability you may be familiar with from Defender for CSPM. As I've mentioned before, we've enriched the cloud security graph with all of the Defender for DevOps' data on your DevOps environment. If I go to DevOps and select code repositories, I can query through all of the repositories on lots of different variables and metadata to select from to identify at a high level all the information I need to ensure rapid remediation of security issues. For this demo, I'm going to click on recommendations, and I want to find all code repositories that have a dependency vulnerability that exists in it. I'm also going to ensure that each of the affected resources are unhealthy. I only want to see which code repositories have dependency vulnerabilities in them and that have not yet been remediated. When I hit search, I can see each of the 11 GitHub repositories in my GitHub environment that should have dependency vulnerability findings resolved. When I click on it, it'll take me back to the GitHub repository from my DevOps inventory and show all the recommendations that are associated with this specific repository. In addition to our enrichment of the Cloud Security Explorer, we now have attack path analysis for your GitHub repositories. Our first one is that internet exposed GitHub repositories with a plain text secret is able to be accessed via an internet connection, aka is publicly accessible. This will identify any of your public repositories that contain a secret in them, allowing for data exfiltration and lateral movement, allowing you to identify the most critical issues need to address. This is the first of many attack paths we aim to add for Defender for DevOps. Lastly, I'm going to show the Defender for DevOps workbook. You may be familiar if you've used Defender for Cloud with workbooks, allowing you to customize, aggregate, and visualize all the data that we collect within Defender for DevOps for any sort of visualization needs you may have, whether it's for reporting, for governance. You can change what you see here using all the data that we store to visualize and report on where your most critical repositories are within your DevOps environments that have the highest risk. Looking at our workbook today, we can show the secrets and which types of secrets are most commonly found in your environments, which repositories have the highest number of code findings, which ones have the highest number of dependency vulnerabilities, infrastructure as code findings, etc. This is just the V1 offering for our workbook. We plan to continue to improve the default offering, but as I mentioned before, you can customize this to fit whatever all your DevOps reporting needs and allow you to visualize the vulnerabilities that exist in your DevOps environments, however you may choose to. So these are all the capabilities that exist within Defender for DevOps today. Thank you all for watching this demo. I'm going to hand things back off to Liana to kick off the Q&A portion of the webinar.
Great. Cool. Thank you so much, Charles. I think that was a really good insight into how to customize this capability with GitHub, and then also how the security admins can actually see all of the results that we have discovered from Azure DevOps, but also from GitHub. So yeah, so in terms of the questions we have, I think there's been a few questions that we want to call out. So I see one question there, and Jason and Valen as well, feel free to add in a few more, but I see one question that we had is is there a way to enforce the requirements? So if our security tools find secrets, does it just let developers know about it, or is there a way to block the code from being deployed until the findings are remediated? So I think for this one, I'll take this one. And basically, one way that you are able to do the blocking is what I showed earlier in the YAML file. So when you're actually running the Azure pipeline, you can set the security DevOps task on, you can set the configuration of that to be break is true. So what that means is that if any security flaws or findings have been discovered by the security DevOps task during the build, then the break will fail. So it'll show that the job as having failed. And then you're able to customize that based on your build validation rules from within Azure DevOps. So that's one way that you're able to manage that process from the earlier on in the process at the Azure pipeline stage. Okay. I see one other, or Charles, do you want to add anything to that one before I move over?
No, you covered it. Just to clarify, that is a Azure DevOps only capability right now, the ability to add a break policy for any secret violations that may be identified in a CI/CD pipeline build. But we look to continue to expand our coverage of this going forward.
Good call out. Yeah, so another question is anti-malware available only for Windows workstations? And the answer is yes. So it's only Windows at the moment. It does require Windows Defender if you're using any custom agents, and it does come completely out of the box with our Windows latest agent. So if you do just want to check for just anti-malware, you're able to set up, this is one possibility that you can do this, but you're able to set up a separate build that actually scans for just anti-malware on the Windows latest, and then if there's malware, then it'll break the build also straight away for that one. So great. Yeah, so another question is, so can we customize secret scanning rules? So can we, for example, modify existing rules and add additional? So yeah, Charles, do you want to take this one, or will I take it?
I got it. So if you want to customize secret scanning, this is available through GitHub Advanced Security. However, it is not currently supported with Azure DevOps. But if you do want to, if you go to the GitHub documentation, you can learn how to customize the findings for the rule set for custom secret scanning.
Cool, thanks, Charles. I guess one more for you because you covered GAS. So GAS, which is GitHub Advanced Security, is that required or is it optional with Defender for DevOps?
So GitHub Advanced Security is required for all of your private repositories. If your repository is public, all of the GitHub Advanced Security and Defender for DevOps capabilities will function on those repositories. However, if the repository is private, like I said, there is a hard requirement there to have GitHub Advanced Security.
Right. And I'll add one additional thing about GitHub Advanced Security, that you can get a 1-month free trial as well for that one. So that is, if you want to test it out and you don't have it, you can do that. Okay, I'm looking back over some of our questions. Is there any other questions from anyone on any of our moderators on the call that we should call out, or will we wrap it up?
We do have one other question. It is, will the DevOps connector only work with projects deployed into the specified subscription, or can the connector be used for projects that will be deployed to other subscriptions?
Yeah, so I see you're referring to Azure DevOps here. With Azure DevOps, you can create a connector for your ADO organizations with any of the subscriptions within your tenant. So there is not a hard requirement for the connector and the ADO organization to exist within the same Azure subscription.
Great. That seems to be all the questions that we had. So with that, I'd like to thank you, Liana and Charles, for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/security-community. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/security-webinar-feedback. Thank you, and see you next time. Goodbye.
Thank you so much, everyone. I hope it was helpful.